then there are no more neighbors for your 0. So we have visited 1, we have visited 2. Now come to 1, explore the neighbors of 1. We have 3 and 4, right? 3 and 4. Once 3 and 4 is done, that is all the neighbors of your 1 is over, we will go to 2 and visit its neighbors 5 and 6. Once all the neighbors of your 2 is over, we will go to 3. Okay, here how we are working? We are going level by level. First level, second level, then third level, fourth level. So this is called breadth first search. Okay, so what we will do over here, we will start from a vertex V. Okay, we will mark it as the visited, then we will visit each element, each vertices on the adjacency list. Adjacency nothing but neighboring list. What we will do, we will create a table like this and we have to create a list. For example, for your graph, given graph, this is the adjacency list. If you take A, okay, B is adjacent to A, C is adjacent to A, D is adjacent to A, E is adjacent to A. Then for your B, we have A, D and F. A, D, F. For your C, we have A and we have G. Then for your D, we have F, D, A, right? A, B, F. Okay. Then for your E, we have A and G, right? A and G. For your F, we have B and D. B and D. Okay. Then for your G, we have C and E. C and E. Okay. This is the adjacency list. If they are asking you to create adjacency list, just create a table with all the vertices name. Okay. Look at the graph. For one vertices, who all are its neighbor, write it in form of linked list. Okay. This is called adjacency list for graph. Now what they are telling in your breadth first search, before, if I am starting with A, I must visit B, I must visit C, D, E. Then only I can go visit the list of my B. Okay. But in your depth first search, we will go to A, we will go to B. From B, we will go and visit the unvisited neighbor of D. Then from D, we will go visit the unvisited neighbor of your D. Then from there, we will go visit the unvisited neighbor and the list goes on. Okay, that is depth first. Here we will first complete everything in the list, then only we will move to the next level. In your depth first search, we have used stack, right? So we have used stack. What and all we are visited, we will push it into the stack. Once all the neighbors has been visited, we will pop out of the stack. Similarly, here what we will use in breadth first search, we will use a queue. Okay, first what should you do? You must create a queue to the size of your vertices. Here we have 1, 2, 3, 4, 5, 6, 7, right? So we have 7 vertices. Create a queue. 1, 2, 3, 4, 5, 6, 7. What should we do? First we are visiting A. Push A into your queue. We will mark. As few people have asked me how we can differentiate visited and non-visited in your answer sheet, because you cannot use other color. You can shade like this and differentiate. Okay. So now what will we visit? We will visit all the neighboring nodes of my A. It is B, C, D and E. Okay. What we will do? We will visit B, C, D and E. Okay. We will mark everything, and once all the neighbors has been visited, what we should do? We should remove this A from the queue. We should remove this A from the queue. Remove the A. Okay. What are the neighbors? B, C, D and E. 3, 4, 5, 6, 7. Okay. What we will do? We will just mark the neighbors. Okay. D, A, E. We have already visited A, right? From A, who all are its neighbors? B is a neighbor, C is a neighbor, right? D is a neighbor, E is a neighbor. Okay. Now, as all the adjacent node of your A has been visited, what we have done? We have removed your A from the queue. Now, what will we do? Once all the neighbor of your level 1 has been visited, what we will do? Who is in the front of the queue? It is B. We have to go see, is there any unvisited neighbor of your B? If you come to B, who all are its neighbors? We have A, which is already visited. We have D, which is already visited. We have one neighbor called F, which is not visited yet. What we will do? We will add F to your queue and we will remove your B. Okay. Write the queue 1, 2, 3, 4, 5. What we will add? We will add F. Okay. Then again write the graph A, B, C, G, D, A, E. Write down the edges. Okay. Now what should we do? We should mark it as visited. These all are visited, right? Okay. Now what should we do? We should go to C. We should go to C and check, is there any unvisited neighbor of your C. For C, who all are neighbors? We have A, we have G, right? Only two neighbors. A is already visited. Who is the unvisited neighbor? It is G, right? What should we do now? We should add G to your queue. We should add G to your queue and we should remove your C. So A, B, C. Okay. Remaining, what do we have? We have D. Sorry. We have D, E, F, and G. Okay. Now we will write your graph as it is over here. It is F, B, A, C, G, E. Okay, and D over here. Is E has been visited? Yes, we have visited from here. See. Is G has been visited? Yes, as it is adjacent to your C. Okay, now we will go check for D whether all its neighbors are visited or not. D having 3 neighbors, A, B and F, all are visited. So what we will do? We will remove D also from the queue. 1, 2, 3. We have E, F, G. Okay, I'll just mark down here so far what all we have removed from the queue. First, what we have removed? We have removed A. Okay, then what we have removed? We have removed A and B. Then what we have removed? We have removed A, B, C. Over here we have removed A, B, C and D. This is the order of visit. Okay. Then we have E in the front of the queue. Okay. So if you see over here, all the neighbors of your E has been visited. So you can remove your E also. I will remove my E. So remaining, what do you have? 1, 2, 3, 4, 5. We have F and G. Is all your neighbor of F is visited? Yes, it has been already visited. So you can just remove everything and you can write like this: E, F, G. Okay. Now what should you do? At last you must write a spanning tree. See, in graph what do you have? you have cycles like this, right? You have cycles like this, but in your tree you will not have any cycle. And what is minimum spanning tree? It should have only the minimum edges between your nodes such that all are connected together. Okay, so if you say 1 2 3 4 5 6 7, there are n number of nodes here. N is 7. What your minimum spanning tree will have? It will have edge of n minus 1, that is 6 edges. Okay, so if you write minimum spanning tree according to the order of visit for your breadth first search for this graph, it will be first we have visited A. From A we have visited B, C, D, E, right? And then for B we have visited from D we have visited, sorry ma,